Hello my dear students, today I will talk about uniform circular motion. So what is uniform circular motion, students? First, in one line definition you can say that when a particle moves with a constant speed in a circular path, its motion is said to be uniform circular motion. Uniform, okay, means it is not variable, not changeable. Okay, uniform circular motion means speed remains same or uniform. Okay, so students, now here the question comes. Maybe the speed remains same in a circular path. If although the speed remains same, you can say that suppose if I talk about a object present at this point A and at this point B, you can see suppose speed remains same at the point A and B, but in circular path you can see its direction always change, because you can see this A, its motion is towards this direction. Suppose V is the velocity. Okay, so always the direction will change. So you know students, speed same with change direction, speed with direction is called velocity. So students, as the direction of the motion change, so velocity also change. So students, here is the thing, just let's understand once again, that suppose a object is moving in a circular path, okay, with same speed, so it is in uniform circular motion, but although its speed same, you can see that at every position its direction has changed. Here you can see it's towards north direction, if this is the north side, north direction, here towards west, here towards south, here towards east. Each and every point A, B, C, D, its direction has changed. So as the direction changed to students, you know, then the velocity will change. So what is the difference between speed and velocity? Velocity is nothing but speed with direction. If a body is moving in same direction along a straight line, then you can say that its speed constant. Okay, means it's going with a speed. But if repeatedly its direction is changed, then the term velocity will come. More properly it will come. So students, if the velocity will change, then the body will gain a acceleration. You know that acceleration is equal to change in velocity in time. Okay, so if the body, then the term acceleration used to come. So let's understand these things once again with proper another example. Okay, students, here the same figure I have drawn once again. You can say at the point V, because with the example if I explain, then you can see that suppose there is a center, radius R, and one object is moving at the point, once it will be at the point A, then B, then C, with same speed, constant speed, means in uniform circular motion. Then its velocity will be, students, at the point A, V means V constant, maybe it can be 3 meter per second, or it can be 5 meter per second, then here also 5, here also 5, here also 5. But at point A, you can see V will be towards east. V towards east. At the point B, it will be V towards north. So direction change means, now I think you can get a concept. So this will be this is called the tangent, that will be perpendicular to radius. Always it will be perpendicular to the radius. The motion of the accelerated motion will be always perpendicular to the radius, and that is called the tangent. So you can say that at any point, listen it carefully, at any point the direction of the motion is along the tangent drawn at that point of circular path. Okay, along the tangent, suppose in this point, along the tangent drawn at that point of the circular path. Now students, I hope it's clear to you that what is the basic things of uniform circular motion. Uniform circular motion means speed remains same, but as the direction of the particle change every instant, so the velocity will change and the body will be accelerated. Up to this portion you need to understand. This acceleration is called, students, centripetal acceleration. So what is centripetal acceleration or centripetal force, I will explain little bit later. But know it, that is centripetal acceleration and the direction acting towards the center. always direction acting towards the center. So let's come here. So thus the velocity of particle in circular motion is variable, or the circular motion is accelerated even though speed is same. This is very important thing, students. The circular path, the circular motion is accelerated even though speed is same. Okay. Now students come, what is uniform circular motion and uniform linear motion? One line has written in your book, circular and linear. By this term you can understand. Linear means speed constant, velocity constant, acceleration will be 0. As the velocity, there will be no change in velocity. Okay, means no change in speed with direction. So there will be no acceleration, means acceleration is 0. So in uniform linear motion, linear means straight line, you know, straight line motion, uniform linear motion, speed constant and velocity also constant and acceleration, hence the acceleration is 0. But in case of uniform circular motion, what we have read up to this point, that the speed same or uniform, here also speed uniform, velocity is variable. Because why velocity is variable? Because every instant the direction of the speed is changing towards its tangent. Okay, according to its tangent, its direction is changing always, each and every point. Here also you can say this point. Okay, so as the velocity is variable, acceleration present. Okay, hence the body is accelerated when it is present in uniform circular motion. Okay, circular in rotation. Okay, now students, the term comes, what is centripetal force or centripetal acceleration? Next point. Let's come to explain this. Students, you can see there is the body, a body at this point, suppose A, B, C, D, it is moving, and you have, I already explained, the acceleration present in that body acting towards the center. This is A, acceleration towards the center, and its magnitude is A is equal to V square by R. In senior class you will learn it about it, how it's come. So direction is change, but magnitude remains same. Magnitude remains same, you know, that means speed remains same, but direction is changed. Hence we know change in acceleration bring about force. Students, here is this line is very important. As the change in acceleration is there, okay, means a particle moving in a circular path continuously changes its direction of motion at each point of its path. This change in direction of motion cannot be brought without a force. Can you understand? Means when this change of, always the change in direction with motion happens, means there is a force acting on it. And this force, you know, according to Newton's second law, force is equal to mass into acceleration. Acceleration is V square by R, so m V square by R. And this force is called centripetal force. And centripetal force brings about centripetal acceleration. Okay, so centripetal force is also called Fc, acting towards the center along the radius. Okay, so along the radius acting towards the center, that is called centripetal force. So what is centripetal force? In one line you can say net force towards the center. Okay, net force acting towards the center when an object moving in a uniform circular motion, then the centripetal force will create. Now students, if we go with some examples, then you can easily understand what are the some examples of centripetal force. Here students, you can see earth is moving round the sun. Okay, if this is the sun, this is the earth. In your book, all the example you read, I am just explaining over here, I am clearing your concept. Okay, so if this is sun, this is earth, you know that there is a force. Fg means a force that is called gravitational force. A force of attraction is present between the sun and earth, means sun is pulling the earth with a force, that is called gravitational force. So here the gravitational force is centripetal force. Fg is equal to Fc. So centripetal force means the force acting towards the center, and it is present in different form. Okay, whenever another force is acting like this way, that you can consider as a centripetal force. Here the gravitational force is considered as a centripetal force. Similarly students, if you think about a nucleus, means in a atom, inside a atom there is a nucleus present inside it and there is the electron. In the structure of atom, you know, so electron is negatively charged and nucleus positively charged as the proton is there. So proton nucleus is attracting the electron. That positive charge attracting negative charge means electron. So there is a force of attraction. This force of attraction acting towards the center, which is known as electrostatic force of attraction, means Fe. In this case, inside the atom, you can say that this electrostatic force is known as the centripetal force. So you understand? So these all types of centripetal force means the net force towards the center. Whenever that gravitational force, here also centripetal force. In this case, electrostatic force is acting, that is called centripetal force. Similarly, students, if you just hold a thread with a stone and just move around like this condition will arise. Okay, so when the stone is moving, a force is acting inside towards the center according to the radius. Okay, towards the center along the radius. You need to remember all the points are very important. Okay, that force is called tension force. Here the tension force is equal to centripetal force. Understand? So I think, students, your concept clear about the centripetal force. What is centripetal force? How it's acting and its direction. Everything has clear. Now, students, there is a fictitious force which is called centrifugal force. Generally it doesn't exist, but to explain the term centripetal force we need to understand the centrifugal force. Next class I will talk about that. Thank you very much.